Okay, so we have this complicated problem that has many parts, but you guys can totally do it. So the first step that we had to do was we had to find the molar mass. And so to find the molar mass, you have to use the rate data. And I noticed that I wrote my equation rate 2 over rate 1. You probably learned it rate 1 over rate 2. It doesn't really matter because it's a ratio. As long as the 2 is across from the molar mass of 1, you're fine. Okay, so I did this math and I calculated that the molar mass would be 60.3, which makes sense because it effused less gas per minute than the neon, which was lighter. So that mass makes sense. And then I have to use my other data because I have to find the empirical formula. So we know when we are trying to find the empirical formula that we need to have percents. So we can find the percent of carbon, like so. We can take 1.46 grams CO2, and all of the carbon had to come from the compound. So I'm going to have 44 grams, that's the molar mass of CO2, in 1 mole of CO2. Then I'm going to have, let's see, 1 mole of CO2 has 1 mole of C in it. And that's going to tell me the moles of C. So when I do that on my calculator, 46 divided 44, I get 0.033 moles of C. And I want to find, so that's equal to the moles of C that is in this compound, but I want to find the percent. So what I need to do is go from moles back to grams. So 1 mole has 12 grams for C. So I'm going to take that, multiply by 12, and I find that 0.398 grams out of 1 gram is carbon. So that tells me that basically the compound is 40% carbon, because this divided by that times 100 is going to be 40% carbon. So I have the molar mass, the percent of the carbon, and now I just need to find the percent of the nitrogen. So I have to use the nitrogen data, and we get a bunch of N2, so I can use PV equals nRT to solve for the moles of N2. So I'm going to substitute 760 is the same as 1 atmosphere. So I have 0.024 times 1 equals nRT. I want N by itself, so divide by RT. Okay, so we have 0.024 divided by 0.08206 and divide by 293. So my moles of N2 is basically 1 times 10 to the negative third. And if I want to find the moles of N in the sample, then I know that for every 1 N2, there's 2 N's. So multiply that by 2, and that's the moles of N. And then the last thing I need to do is I need to find the grams of N. So I would multiply moles by 14 grams. Oops, that's 14 grams. And so I see that I'm going to have 0.0279 grams out of my 60 milligrams. So to find the percent, I need to divide by 0.006, because 60 milligrams I'd need to divide by 1,000 to get to grams. So I have 46% nitrogen, 46.6. Okay, so I have the percent carbon, the percent nitrogen, and I can find the percent hydrogen by taking 100 minus 40 minus 46.6. So the percent hydrogen is equal to 13.4. Okay, This video is getting too long, so I'm going to cut it off here, and I will find the empirical formula and the molar mass in the next one.